Okay, this is asking us to first write an equation for these 2 points, for a line that runs through these 2 points in point-slope form, and then to write it in slope-intercept form. I'm going to try a tool here, which is that I can zoom in on a part of the thing. Yep. So and then I'm going to do the work here, and then I'll zoom back out and do the work on the other one. Give us more space. So what are we doing? First, we're doing an equation in point-slope form. And before we can do that, we have to write the formula for the slope. M is equal to y2 minus y1 over x2 minus x1. Forgive the sloppiness. So then what is y1, y2, x1, x2? So we've got, if that's point number 1, we've got x1 and y1, x2 and y2. And I should not have to remind you at this point that either point could work for point number 1, and either one could work for point number 2. But this is what we've got. So let's first calculate the slope. We say then m is equal to y2, 1, minus y1, 4, over x2, negative 1, minus x1, 1. And then we get what from that? Well, we get 1 minus 4 is negative 3, over negative 1 minus 1 is negative 2, and that resolves to, because it's 2 negatives, it becomes just 3/2. So that's what we get for the slope. And then we have to write it in point-slope form. So we say, okay, we're going to do y minus y1. Actually, let me use a different color just to differentiate it. Let's see. Sorry. Okay, so y minus y1 equals m, parentheses x minus x1. And we're substituting the values in. So let's say y minus whatever y1 is equals whatever the slope is, parentheses, actually brackets, x minus whatever the x coordinate is. Now we have to decide which point we're going to use, and I'm going to just use the first point. So the y coordinate of the first point is 4, the x coordinate of the first point is 1, and the slope that we've got is 3/2. So we get that equation. Because we don't need to resolve any of the negatives. We're not subtracting negatives. So we've got simply y minus 4 equals 3/2 x minus 1. That's the first part of this in point-slope form. And now we have to write it in the slope-intercept form. So what we should do here, I'm going to get this part off, bring it a little bit closer, a little neater. Now what we've got to do is we've got to first distribute this 3/2 to both things. Okay, we're going to eventually write it into slope-intercept form. So we still have y minus 4 equals, when we multiply everything by 3/2, we get 3/2 x minus negative 1 times 3/2 is negative 3/2. Okay? It's the same as negative 1 1/2, but I'm going to leave it like that. And then what do we need to do? We need to add 4 to both sides. Add 4 to both sides, and we will get y equals 3/2 x, and we've just simply got to figure out this part. This is where the zoom tool is great, because what we want to do is negative 3/2 plus 4. So I'm going to zoom in right here and say negative 3/2 plus 4, and that's going to be the same as negative 3/2 plus, that's like 4 over 1, right? Or negative 3/2 plus If I turned it into an equivalent fraction with a 2 on the bottom, that would be 8 halves. And now we can say they both have 2 on the bottom, so we can just do the problem -3 plus 8 on the top. -3 plus 8 is 5 over 2. So we get 5 halves as that, that number that we get right there. Pretty cool tool, right? I'm really enjoying that particular feature, but I'm going to use that more. So -3 halves plus 4 is +5 halves. And that's what we get in slope-intercept form. So point-slope form in red, slope-intercept form in blue. Now, if I zoom back out and say that's all the work for that, now what about all the work for 21? Okay, we're going to do the same thing again. We're going to have over here, and let me actually zoom in here. We're going to say m is equal to what? M is equal to, and let's label the points, x1, y1, x2, y2, and we're going to do y2 minus y1. Actually, let me do this. Let me zoom in. I'm going to zoom in here and say we've got y2 minus y1 over x2 minus x1. Or, parentheses something, minus the other y coordinate over this one minus this one. Now when I'm zooming out, I can say, okay, y2 is 3, x2 is 3, actually putting me in the right spot, y1 is 6, and x1 is -6. So what does that look like? Well, let's see. When we resolve that, we get 3 minus 6 is -3 over 3 minus a -6 is the same as 3 plus 6, or 9. And when we simplify that, we get -1 over 3. So we've got m is equal to -1 over 3. The zooming part keeps me a little bit neater and tighter, so I like it. I'm going to use that. Okay? Now, after we have this slope, we want to now write an equation in point-slope form. Y minus y1 equals m parentheses x minus x1. Okay? So y minus whatever we get for a y-coordinate equals, we've already figured out the slope is -1/3. And let's put brackets here, because we're going to do x minus, and we're going to have parentheses. So we then put brackets on the outside. And which point should we use? I'm going to use the one that's got both positive values for x and y, 3, 3, because then I don't need to resolve any minus -1 kind of stuff. We've just got y minus 3 equals -1/3 parentheses x minus 3. So that is, in point-slope form, what we want. And now we have to write it in slope-intercept form. So I'm going to say, okay, if we did y minus 3, and then on this side, distribute that -1/3. -1/3 times x, -1/3 x, and -1/3 times -3, negative times negative is positive, and 1/3 times 3 is 1. So we end up with a +1. And then the last thing we have to do is say +3, because we want it to read y equals. That's what slope-intercept form does. It says y equals the slope, there's your x, and there is your intercept. So there it is, converted into slope-intercept form. So that one is point-slope, and that one is slope-intercept. And if we shrink back out, you can see our full solutions for both of them. are right there where you're done.